And a warm welcome back to you. My name is Natalie McClutchy and you're watching McClutchy Maths. And in this video series, we're looking at some advanced algebraic techniques. This is our third video in this playlist. We are looking at adding and subtracting algebra fractions. Now in our last video, video 2, we looked at simplifying and multiplying and dividing algebraic fractions. Definitely worth watching. Some of those techniques in that video will be helpful to you in this video as well. So if you're not fully over that one, go and have a watch of that one first. This is aimed at students in grade 10 and up in Australia as part of the Australian curriculum. Particularly useful if you're preparing to study more complex maths in year 11 and 12. If you're overseas, USA 10th grade, but also UK, we're looking at key stage 4 and up. Well, some things you need to remember about adding and subtracting fractions. This goes all the way back to primary school. We need to remember that fractions must have a common denominator. Remember, the denominator is the bottom of the fraction. It must be the same for both fractions if we're going to add them or subtract them. So, for example, I can't add a half to a quarter until both the denominators are the same. Now, the way that we do that is we find the lowest common denominator of both the fractions, and then we multiply the fraction by that common denominator. So here, I could see that the 2 and the 4, 2 divides into 4, so I want to make both fractions a fraction out of 4. So I'm going to multiply the half on the top and the bottom by the number 2. Basically what I'm doing is not actually changing the fraction, I'm actually making an equivalent fraction. I'm multiplying it by the number 1. Remember, when we multiply something by the number 1, and the number itself doesn't actually change. But this is the number 1 in the form of 2 over 2. 2 divided by 2 is 1. So if I multiply a half by 2 over 2, what I end up with is 2 over 4. So now I've got 2 quarters plus 1 quarter. I can now add those together to get 3 quarters. So this is the principles you need to remember as we're going through this video. Okay, so let's get right into it with some algebra. 3 quarters take away k over 2. Now I've chosen this example specifically because it's very similar to what we just did using quarters and halves. So you can see that I'm going to be changing this fraction only because 2 divides into 4. A common thing people do is to make them fractions out of 8. Just multiply this one by that one. You could do that as well, but it means you're going to need an extra step later on to simplify those fractions. So it's better to be savvy straight up front and think, I only need to change the one fraction in this case. So always rewrite your question underneath and get started and work with that particular version. There's reasons for that. First of all, it keeps it neat and tidy, but also it means you've always got your original question to refer back to when you're checking your work. So now I've recognized the only fraction I need to change is this k over 2. I'm going to multiply it by the number 1 in the form of 2 over 2. So I'm going to multiply the top by 2 and the bottom by 2. So what I'm going to end up with is 3 quarters take away 2k over 4. So now that I've got 2 fractions and they've got the same denominator of 4, what I can simply do is transform that into a single fraction with the same denominator. So here, because these are both 4, I can make one fraction with a 4 as a denominator, and the numerators are joined together now and subtracted. Now, I can't simplify that any further, and the reason for that is that 3 and 2k are not like terms. So I'm simply going to leave that as 3 take away 2k over 4. Now the tempting thing for people to do here is to try and do some more further cancelling. They might be tempted to cancel that out with that one there, but you need to remember it's the whole thing here divided by 4, not just that part there. So yes, you could end up breaking those 2 fractions apart, but it really doesn't simplify it at all. It'll just take you back to the beginning. So combine it as one fraction and leave it there. Okay, worked example 2. We've now got some slightly more complicated fractions, and you'll notice that this fraction does not divide nicely into that fraction. 2 does not go nicely into 5. We need a different common denominator this time. So I'm going to write that a little bit bigger underneath so that I can start working with it. Now, this is where if this fraction here, if this denominator does not divide nicely into that one, we simply multiply the 2 together. That's going to be our new lowest common denominator. We're going to have a lowest common denominator of 10. So what that means is, to get there, I've got to multiply this fraction by 1 in the form of 5 over 5, and this fraction by 2 in the form of 2, or it's multiplying it by 1, but in the form of 2 over 2. So that's going to look like this. I'm going to multiply this side by 2 and that side by 5. Okay, now it's very tempting to just multiply the first term by 5 here and the first term by 2. But remember, everything on the top is being multiplied by 5. And that's why I like to leave it in factorized form. So we're actually going to put these algebra expressions, y plus 3 and y minus 2, we're going to pop them in brackets and leave them in factorized form initially. So now we've got this common denominator of 10 for both of the fractions. So you'll notice here what I said before earlier, 5, and these will be in brackets, 2, these will be in brackets. So now that I've done this, I can now make it one fraction. Because they've both got the same denominator, I'm going to bring the tops together and the bottom will simply become 10. So now you can see this looks a bit yucky. It's just all one thing. But now is where I'm going to do my expanding. So I'm going to expand those brackets. 5 times y gives me 5y. 5 times 3 gives me 15. 2 times y gives me 2y. And 2 times negative 2 gives me negative 4. So now that I've got this in this form, now I can do some simplifying. I can actually collect some like terms from the top here. 5y plus 2y makes 7y. 15 take away 4 makes 11. So I've actually just simplified this now to 7y plus 11 divided by 10. In my third worked example, we're going to do something a little bit similar as well. You can see we've got different denominators here, so I can't just add them together. I'm going to have to multiply this side by 4 over 4 and this side by 3 over 3 in order to be able to get a common denominator of 12. So let's do that. Multiplying there by 3, multiplying by it by 4. Once again, we're going to leave everything in brackets in factorized form. So we've now got this common denominators of 12. We're going to bring the tops together now and have a single denominator of 12, so it'll be one big friendly fraction. And we're going to do what we did in our last example, we're going to expand those brackets. So 4 times 2m gives me 8m, 4 times negative 1 gives me negative 4, 3 times m gives me 3m, and 3 times negative 1 gives me negative 3. Now it's time to collect those like terms. I can see I've got 8m plus 3m will make 11m, and I've got negative 4 take away 3 makes negative 7. Always remember that sign in front goes with the term afterwards. So now I've got that, and it's simply 5m take away 7 over 12. Can't simplify that any further. And here's our next worked example. We're going to do a bit of subtraction. And this time we've got algebra on the denominators. That's kind of yuck. But we're going to follow the exact same principles that we've been following with whole numbers on the denominator. So firstly, let's rewrite our question. Now, you might be thinking, well, what's going to be the common factor? And you might be tempted to look and go, oh, it's just j. So that's not actually correct. This fraction is actually divided by j take away 6. This is divided by j plus 2. That's the whole denominator there. So when we had a 3 on the bottom and a 4 on the bottom, we multiplied the two together. And then we multiplied the opposite side by the opposite number. We're going to do the same thing here. We're going to multiply this fraction on the right-hand side by the denominator of the left-hand fraction. And over the other side, we're going to be multiplying that one by the denominator of this side here. So you can see that there's that cross multiplying going on. Once again, leave it in brackets. So you can see here, this j plus 2 has come over here from the top down there into brackets. This one here has come into brackets as well. And when I've multiplied those denominators, I'm leaving those in brackets. It's tempting to factorize, to expand it out. We don't need to expand it out at this stage. So leave those in brackets. Okay, and now we're going to do, we've got common denominator here and here. So we're going to bring those fractions together just like we did when we had the whole numbers. So now I've got this from up here, take away that. And this one here becomes a single denominator. Now, we're going to actually expand the top only. I could expand the bottom using FOIL techniques. It's a binomial expansion, but unless I'm asked to, there's no real need to. So let's just expand the top. So now I've got 3 times j makes 3j. 3 times 2 makes 6. Negative 2 times j makes minus 2j. Now be really careful with the next one. Negative 2 times negative 6 makes positive 12. And that's probably where a lot of students will make their first big mistake with this one, is expanding those brackets. So now I'm going to collect the like terms. I've got 3j, take away 2j makes a single j. 6 plus 12 makes 18. I've got j plus 18. I could choose to expand that if I was asked to, and if I wasn't asked to, I may even want to just hedge my bets and expand that out using binomial expansion techniques. Either way, you've simplified the question significantly. Okay, here's our final example for today. We've got 3 over n plus 1 plus 2 over n plus 1 squared. I've brought some powers in. Might look a little bit scary. You just need to recognize that n plus 1 is a factor of n plus 1 squared. So all I need to do to give them a common denominator is also multiply this fraction over here by n plus 1. And then I'll have this denominator of n plus 1 squared. So let's do it. We're going to multiply both parts of the left-hand fraction by n plus 1, leaving it in brackets again. So we've got now 3n plus 1, and we've got this common denominator of n plus 1 all squared. So now I could bring the denominators together, I could bring the numerators together, and now it's time to expand those brackets. 3 times m makes 3m, 3 times 1 makes 3, and simplify that numerator by collecting the like terms. 3 plus 2 makes 5. I could also, once again, as I mentioned in example 4, I could expand the bottom out. That would become m squared plus 2m plus 1. I don't necessarily need to, it's not essential, but you may just wish to do that if you're wanting to hedge your bets either way. Well, did you find our 5 examples helpful today? Did these techniques further you on your mathematical adventures? Well, here's some ways you can engage further with me at the channel. First of all, like and subscribe, hit that notifications button so you'll always know when my next video is coming out, and there's going to be a lot more in this algebraic techniques series. You could share this video if you're a teacher with your class, pop it on your OneNote page, or you could even share it with a friend or a family member. There's that little arrow link up the top where you can share the link there. Why not tell us in the comments if you found the video helpful, and follow us on Facebook and Instagram. But if you've got any questions about anything you saw today, the place to contact is mcclutchymaths@yahoo.com. Writing it in the comments, very complicated, especially now that we're looking at some algebraic techniques with some complicated fractions. So feel free, if you've got an algebra fraction you need to simplify, shoot that over to me and I'll give you a hand. Well, you've been watching McClutchy Maths. I'm Natalie McClutchy. Have a wonderful day.